In this video we're going to look at how to find values of a random variable given probabilities for the random variable. So let's have a look at how we're going to do that by means of an example using the adult male giraffes that we looked at in the previous video. And they are distributed with a mean of 505 centimeters and a variance of 650 centimeters with the normal distribution. So if h is the height in centimeters of the next giraffe to be seen, h is normally distributed with a mean of 505, a variance of 650, or we can write the variance as being 25.495 squared, where 25.495 is the standard deviation. So what we're after is the probability that h is less than x has got to equal 0.9. Okay, and we can think of that in terms of a picture. There's our distribution of the heights of the giraffes with a mean of 505. What we're trying to find is the value little x, so that the probability that the height is less than little x is equal to 0.9. In other words, the area underneath the graph to the left of little x has got to equal 0.9. Now we can do this calculation easily on our calculator again. We need to start off menu 7. This time we go 3 for inverse normal. We want to put the area to the left in, which is 0.9 in this case. We need to put the standard deviation in, which is 25.495. And we need to put the mean value in, which is 505. And then press equals and equals again, and that will tell me that the value of little x is 537.7. So let's just go through this process of finding x once more on the calculator. So we need to go menu 7 to get the stats options available, then 3 for the inverse normal ones. Put in the area to the left that we've got, then the standard deviation, and then the mean. And when we've put the mean in, we need to press equals twice, and that then will give us the value of x as being 537.7. Now it is important to realise that to use the inverse normal facility on the calculator, we must know the mean of the normal distribution, the standard deviation of the normal distribution, and the probability of the tail going from the required value to the left. Okay, so let's now move on to a second example then. In this case, we're being told that there is a 0.52 probability that a randomly chosen adult male giraffe of this species has a height between 500 centimeters and y centimeters. We've got to find the value of y. So, we've got the probability that the height lies between 500 and y is 0.52. Representing that on a quick sketch diagram of our distribution, we've got there that the normal distribution with mean of 505, and we've got the area between 500 and little y has got to be equal to 0.52. Using the probability calculator, not the inverse probability calculator, but the probability calculator, we can determine that the probability that h is less than 500 is 0.4223. So that gives me the area of the tail from 500 going out to the left. From that, I can now say that the probability that h is less than y is 0.52 plus 0.4223. So that gives me 0.9423. Now I can use the inverse probability calculator that we introduced in the previous slide. Okay, and if we do that, we will determine that y is 545.1 centimeters. Now again, at this stage, I think it's important you just pause the video and use the inverse normal probability calculator to get that value of y being 545.1 centimeters on your calculator. So check that you can do that. So moving on, completely new example. We've got times taken by 12-year-old children to run from one end of their school's playing field to the other end can be modelled by a normal distribution with mean 83 seconds and variance 62 seconds squared. Find the probability of the time taken by one of these children to complete the run between 67 and 85 seconds. Now that's a nice straightforward probability calculation. So we've got if t is the time for a randomly chosen pupil to complete the run, then we can say that t is normally distributed with mean 83 and variance 62. In other words, the standard deviation is the square root of 62 or 7.874. So we can say instead that t is normally distributed with mean 83 and variance of 7.874 squared. So the probability that t lies between 67 and 85 is 0.5791. That's just using your probability calculator. Find the probability that in a randomly chosen group of 10 of these children, more than 7 of them complete the run in a time between 67 and 85 seconds. Well, if we let y be the number of children out of the sample of 10 who run in a time between 67 and 85 seconds, then y could be modelled by the binomial distribution with n equals 10 and p equals 0.5791. We are assuming that the running times of these 10 children are independent of each other and that each of the children has got a probability of 0.5791 of completing the run in a time between 67 and 85 seconds. Now, the probability that y is more than 7 is 1 minus the probability that y is less than or equal to 7. And if we use the binomial probability calculator, then we obtain that as being 1 minus 0.8641, which gives me a probability of 0.1359. Moving on to part C, then we want to find the time for this run that is exceeded by 95% of the pupils. So, suppose 95% of the pupils take at least t seconds to complete the run. That means that just 5% of the pupils take less than t seconds to complete the run. So what we're looking for is the value of little t such that the probability that the random variable capital T is less than little t is 0.05. And this is a calculation we can do straight away using our inverse normal calculator. And that gives us t equals 70 seconds almost exactly. Now again, just pause your video and use the inverse normal calculator to check that if you've got an area of 0.05 going out to the left with a standard deviation of 7.874 and a mean of 83, then the resulting value is 70 seconds. For our third example, we've got the mass of standard loaves produced by a bakery are normally distributed with mean 470 grams and standard deviation 4.6 grams. For the first part, without doing any probability calculations, write down the probability that a randomly chosen standard loaf from the bakery has a mass of exactly 473 grams. Well, if m is the mass of the randomly chosen standard loaf, the probability that we get a mass of exactly 473 is the probability that the value of m lies between 473 and 473. We know that probabilities correspond to areas, and the area underneath the graph of the region representing 473 is less than or equal to m is less than or equal to 473 is exactly 0. For the second one, what's the probability that we get a mass which is less than 500 grams? Well, we know that mu plus 5 sigma is mu, which is 470, plus 5 times 4.6. So that's 470 plus 23 is 493. So we know there is next to no area beyond to the right of 493, which certainly means there's no area to the right of 500. So that means that we know that all the distribution, or virtually all of the distribution, is less than 493 grams. So virtually all of the distribution is less than 500 grams. So we can say that to a high level of accuracy, the probability that x is less than 500 is going to be equal to 1. For part B, we've got to calculate the probability that a randomly chosen standard loaf has a mass of at least 480 grams if it is known that the loaf has a mass of at least 475 grams. Now, this is a conditional probability. So, we're after the probability that m is greater than or equal to 480, given that m is greater than or equal to 475. Using the rule for conditional probabilities, that's the probability that m is greater than or equal to 480 and m is greater than or equal to 475, divided by the probability that m is greater than or equal to 475. Now, if we know the mass of the loaf is greater than or equal to 480, and we're also told that the mass of the loaf is greater than or equal to 475, then those two statements together combine just to tell me that the mass of the loaf must be bigger than 480. So what we've got to do is obtain the probability that m is greater than or equal to 480, and then we've got to divide by the probability that m is greater than or equal to 475. We can obtain those two probabilities from the probability calculator for the normal distribution, and they give me 0.01486 divided by 0.13853, which gives me a conditional probability of 0.107. For the final part of the question, we've got to find the value of little x if it's known that 86% of the bakery's standard loaves have mass between x and 482 grams. So, putting that information on the diagram, we've got the area between little x and 482 has got to be equal to 0.86. Using the probability calculator for the normal distribution, I can say that the probability that m is less than or equal to 482 is 0.99546. So that means that the probability that m is less than or equal to x must be 0.99546 minus the 0.86, which is the probability that I am between x and 482. So I've got the probability that m is less than or equal to x is 0.13546. Using the inverse probability calculator for the normal distribution, that now gives me x is 464.9 grams. So that was using the inverse normal calculation with an area of 0.13546 going out to the left from little x. The standard deviation of the distribution is 4.6 and the mean for the distribution was 470 grams. Check that you get that answer on your calculator. And to finish this video off, there are a couple of questions here for you to have a go at where you will be required to use both the probability calculator for the normal distribution, but also you'll be required to use the inverse normal calculator. And that concludes our look at finding values from probabilities.